Hey guys, it's a boy Tur, and today we're gonna have a tutorial about functions. But before we get into that, we have to learn first about relations.
A relation is defined as a correspondence between two sets of objects. It can also be defined as a mapping or pairing of input values with output values. The set of input values is called domain, while the set of output values is called the range. Relations can be represented either through set of ordered pairs, table, graph, mapping diagram, or equation. One type of relation is a function in which no two ordered pairs have the same first component. So looking at these examples, group A is a function because there are no ordered pairs that have the same first component, unlike in group B, which has 2 number 1 and 2 negative 1 as the first component. The same goes for map A and B, and table A and B. In order to check if a graph is a function, one may use the vertical line test. The vertical line test says that if any vertical line passes through more than one point of the graph, then that relation is not a function. So for this example, graph A is a function since the line only passes through one point, unlike in graph B where the line passes through 2 points. Function notation simply looks like this, where y is the output, f is the name of the function, and x is the input. For example, this function is read as f of x equals 4 times x minus 3, where x is the independent variable and y or f of x is the dependent variable.
Transformations happen to a graph when there are shifts, either vertical or horizontal or both. A vertical shift happens when the graph moves vertically, either up or down. Here is a guide table for graphing, assuming that C is a positive constant. So, if the operation is addition, the graph will move C units upward. But if the operation is subtraction, the graph will move C units downward. A horizontal shift happens when the graph moves horizontally, either to the left or to the right. Here is another guide table for graphing, assuming that C is a positive constant. If the operation is addition, the graph will move C units to the left, but if the operation is subtraction, the graph will move C units to the right. For example, given the original equation f of x is equals to x squared, the graph looks like this. If we are to add a vertical shift, the equation will be f of x is equals to x squared plus 2, which will result to the graph moving 2 units upward. And if we are to add a horizontal shift, the equation will be f of x is equals to x minus 2 squared, which will result to the graph moving 2 units to the right.
When horizontal and vertical shifts are combined, the graph moves either to the upper right, upper left, lower right, or lower left. However, the process of solving and graphing is still the same. The only difference is that two transformations happen. For example, the original equation f of x equals x squared has a graph like this. If we are to add both horizontal and vertical shift, the equation will be f of x equals x plus 2 squared minus 2, which will result to the graph moving 2 units to the left and 2 units downward. Another example. If we have the equation f of x equals x minus 1 squared plus 3, the graph will move 1 unit to the right and 3 units upward.
When adding functions, you just simply substitute the expression to the function name and simplify the expression. The function of f plus g of x is equal to the function of f of x plus the function of g of x. For example, let us solve for the function of f plus g of x where x is equals to 4, and f of x is equals to 2x plus 1, and g of x is equals to x plus 5. Given by definition mentioned before, the function f plus g of x is equals to the function of f of x plus the function of g of x. So now we will substitute 2x plus 1 to function f and x plus 5 to function g, and we'll do the arithmetic. And now the function of f plus g when x is equals to 4 is equals to 18.
The process of subtracting function is the same as adding functions. The only difference is the operation. You just need to substitute then simplify the expression. The function of f minus g of x equals to the function of f of x minus the function of g of x. For example, we are given f of x is equals to 5x plus 3 and g of x is equals to 2x minus 2. Let us solve for the function of f minus g of x if x is equals to 2. Let us substitute 5x plus 3 to the function of f and 2x minus 2 to the function of g. After substitution, let us now solve. The function of f minus g when x is equals to 2 is equals to 11.
Multiplying functions is similar to multiplying algebraic expressions. In this case, you need to substitute the values of functions and simplify them just like when adding and subtracting functions. The function of f times g of x is also equals to the function of f of x multiplied by the function of g of x. For example, let's solve for the function of f times g of x, where f of x is equals to x plus 6 and g of x is equals to 3x plus 1 when x is equals to 3. X plus 6 is substituted to function f, and 3x plus 1 is substituted to function g. The function f times g of x is equals to 90 when x is equals to 3.
Division of functions is also similar to division of algebraic expression. Substitute, perform the operations, and simplify the expression.
The function of f divided by g is also equal to the function of f divided by the function of g. For example, given the function f of x is equals to 3x plus 5 and g of x is equals to x minus 1, let us solve the function of f divided by g of x where x is equals to 5. Let's substitute 3x plus 5 to function f and x minus 1 to function g. After solving, function f times g of x is equals to 5 when x is equals to 5.
Given two functions f and g, the composition of f with g is defined as f composed g of x is equals to f of g of x. In this case, you will substitute the whole function to the x of another function. For example, given the functions f of x is equals to 2x plus 3 and g of x is equals to 5 minus x, let us find the composition of f with g. F composed g of x is equals to 2 times quantity 5 minus x plus 3. That is because we substituted g of x to the x of f of x. And to simplify, we will have 13 minus 2x.